Hi, I'm Sasha, and this is the fourth video for UniSQ MTR1201 Millie's Flying Fish. This video focuses on the module Sensors Calibration. During parts 1 and 2 we constructed the body, wired everything up, and set up the servo. This module builds on part 3 where we interface with the MPU 6050 and converted the raw sensor data into Gs and degrees per second. We also calibrated the gyroscope to remove bias. The goal of this module is to convert the rotational momentum data obtained in part 3 to rotational position data by integrating it. A new flowchart and program, as well as some tests akin to those in prior parts, are required. Compared to the program in part 3, the new program for this module has the following important changes. First, much of the accelerometer-related code has been removed, as we are specifically trying to determine the rotation of the fish within this module. Second, a new section has been added to the loop to calculate the loop time. Third, we now integrate the rotational momentum values from before with the loop time to calculate the rotational value for each axis. These are then printed out, but only every 500 milliseconds or so to reduce excess logs. Finally, delay between loops has been reduced to 50 milliseconds, meaning shorter loop time, which improves accuracy. Beside these changes, the main code stays roughly the same. Now moving on to tests. I've placed the fish on top of my marked sheet of paper here. I then turn on the device whilst it's aligned with the 0-degree mark. As shown in the logs, when I rotate the fish to the 90-degree mark on the paper, a number very close to 90 degrees is printed to serial. I can then return to the 0 position and the rotation returns to 0. I can also repeat this test in the opposite direction and see similar results except with the opposite sign. Secondly, here is a 5-minute time-lapse of the logs whilst the fish is held still. As you can see, whilst the value does drift slightly, it's fairly minimal. Thus, I'd consider the program and sensor to successfully produce accurate rotational position data with minimal drift. This concludes part 4. Thank you for watching.